Okay, guys. Starting a new stream. We are back in the business. Let me share the stream here. Kicking off a training run in this one. So that's the plan. Let me open up the live chat. Amazing. So again, the plan is we are done sharding the data. We are done binarizing the data. The time is now ripe to start kicking off training runs. We're gonna kick off a test run, see whether we hit any issues, and then we'll start iterating. There is a lot of components where we want to iterate. We want to iterate on the data side, on the source side. We want to iterate on the filtering. We want to figure out whether there are any bugs along the pipeline, and then obviously experiment with different hyperparameters, with different sizes. There is a ton of work that we'll be doing over the next period, but this is super exciting. Basically, the data preparation pipeline is now ready. As you can see here, let me see, this is empty. We don't have any eval data sets. And then we now iterate here. Let me just see what we're doing. We're creating some symlinks. So target path, process data, data bin, shard 0. We want to symlink that with dictionary. Why? Aha, makes sense. Okay, got it. Let me just make sure this makes sense as the target path. So again, prepare data, process data, data bin shard 0, data bin shard 0. Okay. And then shard 0. Just a second, shard 0. And then ACE Arab txt. We need to link that to the actual source dictionary, SPM 200. Okay, that makes sense. Let me just see where those files are. TXT files are where exactly? Maybe at the end, maybe. Or is that just, okay, no, that's actually, yeah, well, that's just a symbolic link. So let's create that. And then we do the same thing for the target languages. And then after we are done with that, we can exit and we basically remove this temporary directory and we are done. That's it. Hit F5. We are done. That's ready. We have all of our shards are here. Here are these symlinks. I assume that here we only have a couple of files, and the closer we are to the 0th shard, every direction will have 0th shard, but not all of them will have these later shards. I'm actually surprised that, okay, Turkish is mostly present here. Turkish, Latin to Russian Cyrillic. Turkish and Russian seem to be very much present. Okay. Let's kick off a training run, guys. We have our data. Everything we need is in data bin. Yes, hi SQ, we are training. We have our data here, we have shards right here, and we are ready to start training. Awesome. Let me just add some to-dos for later. We're done with this. Okay. Let's try and kick off a run. Let me copy path here. Let's go to parsec. Let's go to train script. Let's open up the configs. Yes, the smallest one. We'll just kick off some test run. Base config. We're gonna grab this one. Let me see what did I modify here compared to the original one. Okay, as you can see, 1212. I think that's gonna be the small one. There's a root model checkpoints. Go there. Data. We're gonna specify data probably somewhere else. Let me see what else we wanna set up here. Number of GPUs, learning rate, maximum number of tokens. Why is this so small? Why do we have only 250 tokens? That's interesting. Okay. This looks okay. Let me just double check. First, let me just copy the data. We probably want to put it here. Let me just see. The fine tune on FP seed. Is using FP seed chat. So let's go there and let's just set the data prefix, data path. Let's quickly see in the paper, 600 million layers. Let's see where they mention number of layers, 12. Okay, we use a 12-layer encoder and decoder and train for 100 epochs. Okay, but that's for mining. Okay, they mentioned something here. NLLB performance, results. $4,096, 16 attention heads. What are the baselines? Let's just try and search for baselines. Maybe that's gonna be better. Baseline. I I think their only model is, only the distilled model has 12 layers. Okay. Trying to find. If anybody finds it before me, let me know. Baseline 3.3 billion. Okay. Okay, here it is. And the 615 million student model performs better than the baseline. Dense baseline. 650 million. Let's try and search like that. $200K updates. Okay, let's see this chapter. We finally explore distillation. Okay. Trying to find the number of layers for the 650 million parameter model. I'm not seeing anything, but I think we can just... Okay, there is this mention here in table 47 of a smaller model, but they don't mention how many. So I assume around 12 layers makes sense. Okay, so let's go back here. Again, let me see, what did I change? Only the setup, how many GPUs and how many nodes we have. Root, output, architecture, that's it. All of that is reasonable to change it. Let me see, max updates. I'm not sure what this is. What is max updates? We'll see soon. Max tokens 250. That seems like a too small of a number. Max tokens 4096. That is probably context length or what? Looks like context length, definitely. Max tokens. Okay, let's open up one of these side by side and let's see what's the default value. This is default. Okay, I think I changed some variables here as well. Okay, I did change the architecture. This custom model uses smaller, dense. Yes, I did find that paragraph. Yes, I did. Thanks, XU. I think that's some specific. I'm not sure whether that's the 650 million though. Let's open up this side by side. Let's open this config here. Let's open up the default one here. And let us see whether some of these changes make sense. Warm up 8,000. Here we only have warm up of 10. Whereas, let's see these guys, warm up 400, warm up 1,000, warm up 8,000, 8,000. So 10 is definitely too small. Let's put a bit bigger number, like 500 here. We'll see later what exactly we're doing here. I'm not sure how many steps do we have here. What's the max token? Max tokens 4,096. Let's put 2048 or something. Let us put 2048. Max updates 100,000. Okay, so that seems reasonable. Because they did mention 100,000 steps and 200,000 steps. So then maybe we can just leave this as default. What's warm up for the default model? 8,000, okay. What's the LR schedule? It's not specified. LR001 update frequency 2 max tokens, okay. Max time in minutes a bit longer. Temperature 1, fully sharded. Encoder token, all of that seems reasonable. False, this is true. Synchronize. Best checkpoint metric. NLL loss. Keep interval updates 10. Save interval updates. Okay, let's say every 1,000. I'm gonna save. Same here. Validate interval. I don't know, every 500. We'll set that up later. Output directory, fairsec root, train subset, architecture, prefix dense, okay. And then let's open up the dense config, set to dense, and everything else is null because we're not training mixture of experts. Data set is gonna be chat, cluster is gonna be example. I'm not sure if we kick off partition dragon. That's my That's the name of my Slurm partition, by the way, Dragon. I'm just thinking whether we want to run it locally, so set this to null maybe. Let's see, we'll see in a second. And then everything else is just default. Which is here. So two questions. One is, do we want to put local for the cluster? And the second question, is this representative, this particular FPC chat? Let's see some other data sets like this one. I think the main difference will be that these ones have SSL, like monolingual data as well. Number of shards, 1. Here we have number of shards, 32. I'm not sure whether that should correspond to the max number of shards or what. We'll see soon enough. I think we have 28 shards. So if we take a look at Stopes, here we have 28 shards. So should that be that number or what? We'll soon see. Languages file, pair file, okay. And then there is the mono. So if we ignore this, these are the same structure. Okay, we can grab this. This looks like a decent config. Which language pairs do we want to train? We can here just compute. We can here, for now this does not matter really. We can just put a couple of random directions. Later we can link a path and make sure that that path contains all of the relevant directions. So yeah, let's put maybe a couple more. Let's go to Stopes. Let us go to train corpora. Maybe a couple more directions, like maybe Russian, Cyrillic, English. I assume this should be comma separated values. And then let's find like Turkish, something like, or maybe German. Do we have German? I don't think we will have German. Let's see, Portuguese, Latin, Portuguese. There is a translation between. Okay. Turkish. Turkish and Russian, something like that. I don't know. I know those are fairly, they have a lot of sentences, these directions, if I recall correctly. Okay, so what is left to see is number of shards and whether we want to run locally. So let's maybe set this to null. That means local. And let's go to transcript. Okay. Let's open up these configs on the side so that we see whether we want to set up anything additional. Cluster name. I think I gave my Slurm cluster some name. I forgot. How do I see that? How do I see the name of my Slurm cluster? Was this Slurm config file? I remember I've set some name. I'm not sure whether that has to correspond directly there. Maybe slurm. Let's see, slurm. Just a second. I'm gonna find my slurm. Development notes. Slurm config. And slurm db config as well. Aha, okay. The reason I'm not finding it because I'm looking under current directory. Let's just go and find it like this. Okay, here it is. etc slurm. Whoops. Okay. Just see the config here. Cluster name, very creatively named local cluster. That's my cluster name. Okay. Dataset config. Let's open up this and let's compare it side by side. Dataset name, number of shards, languages, length file. I'm not sure what's length file. And then there's a pairs file. Okay, I think, well, file is you specify an actual file, and pairs is you specify directly the pairs instead of the file. Makes sense. Okay, fair enough. And then eval, and then data prefix. Okay. Then let's go model type config. Nothing special there. Okay, guys, I think this is ready. We might need to change the number of shards for the dataset, and we might need to specify the slurm partition as opposed to setting it to null. But let's kick this off. We are ready. Let me see whether the right one is specified here. 3.3b fine-tune on. This is a misleading name because we changed the architecture, so it's not really 3.3b. But bear with me. Fine-tune on FB seed. That's it. Let's kick it off. No arguments. Let's go. Train module. Saving the output directory, which is going to be what? Model checkpoints. Fair enough. Let me close this. Close all. Okay, we drop into model checkpoints. We're going to drop the train script YAML. Directly in the fairsec root under model checkpoints. So here, train script YAML, cluster name, local cluster. Assert that the cluster name is in data prefix. Okay, I see what I've done there. So I have to, if we change, I'm not sure whether this is important, but yeah. Anyhow, let's set this here to local cluster. Let's rerun the train script. We are here. 5. That's good now. We grabbed the data prefix, which is the binarized data we just obtained a couple of hours ago. Make sure this exists. Make sure we have the read access. And then for the number of shards. Okay, yes. Yes, so that means we have to specify number of shards precisely. That's one question less. Let me go to FPC chat. Number of shards is 28. Okay. Let's stop. Let's rerun. I love this iterative learning. We're just learning stuff and then modifying as we go. Almost there. Ready to kick off the run. So it's just adding this special syntax with colons. And then we end up with a huge path. And then we remove the leading column. Here it is. And then we save that. Okay, guys. Launch the job. Let's see. Nothing specified there. If we have the languages, assert the file is not none then, and then we join the file. Here are the languages, specified as a file, and then languages pairs specified directly, and then we don't have eval at all. Checkpoints activations, we don't have them. 0, we did not specify 0. None there, none. No SSL task. Here is the final sweep command. And then we can run it. But what I will prefer is to grab these arguments and then basically run them ourselves. That's going to be the idea. Okay. Let's maybe quickly iterate over this to see what we've set. Here's a root, that makes sense. Sweep MMT, data directory, train prefix, we're training a dense checkpoint. Checkpoints is model checkpoints. Okay. Partition set to none. I'm not sure whether that's going to work. Let me see currently in some of these long JSONs I've played with before. Do I have partition set? I do have. It's set to dragon here. Directory, this guy does not have any. Okay. We'll see how that goes. We'll probably have to remove the partition flag altogether. Number of trials 1, number of nodes 1, GPUs 2, that's how many GPUs we have. Max time in minutes. This is probably just a timeout function, so we cannot train for longer than what? 3 hours and 20 minutes. We have 0 memory, that's bad. Let me check, what did we set here? Memory 48 gigabytes. We might have to change the memory as well. Otherwise we don't get. Let me just see again. I think this is needed for the Slurm cluster in particular. Okay, where did we stop? Sampling method temperature. Sampling temperature set to 1. Decoder length talk. Encoder set to source. Languages set to a path. Language pairs. Fully sharded. Number of updates 100,000 steps. Okay, synchronize checkpoints before the copy, true. Max number of tokens. Learning rate 0.0005. Atom 16-bit. 1000. Okay, save interval update. So every 1000 steps we save a checkpoint. That's how I understand that one. Save interval. Tensor board. Location, okay. Architecture 12 by 12 transformer. Every 500 steps we run the validation. Simling best and last checkpoints. Best checkpoint metric is NLL loss. Seed set to 2. Interesting. Train subset set to train. Snapshot code. Use local shard size. Enable M2M validation. Add data source prefix tags. Replication count should be 1, I guess. Checkpoint activation 0 param. Okay. None. Restore file. Fine tune from model. No save. Log interval. Reset data loader. Reset all. Okay. Hit F5. Here is the sweep command. Let's just dump it here. And let us basically extract it. I just wonder one thing. My cluster, so I guess the only thing we have to specify potentially memory, and we have to specify the partition. Okay, so let's see what is specified here for partition. Just none. Okay. Let me grab this. And now for the painful task of actually parsing this. Maybe we can automatically just process it by writing a small script because I'm lazy. Okay. Fine tune. Distributed world size. How did I get that? I have no idea. I think we're the most similar to this one. So that means we have to set partition and memory. Let me see whether we are literally the same as this one. We can just replace a couple of thingies. So how do we check that? Let's split this on the right. And let me paste this here. Okay, I have an idea. Let me quickly open up a file. Next to train script. I'm gonna call it parse_py temporary command. And then let's just parse it. So let's call split, and let's print this. This should already be like enough to sort this out. Okay, looking good. Let's just copy paste this. Copy, go to launch, and next to fine tune, because we said that one is the most similar. Generate fine tune, either direct train or fine tune. Okay, let's just paste it here for the second, and then let's grab this one. Let's just copy paste it. Okay, snap. This requires us to have obviously double quotes. Let's just replace the single quotation with double so that we can just copy paste this here. Where is the train script? Okay. How does one do that? So I just want to replace the single with double. What's the command in Python, guys? Anyone? Python replace character in string. So string and then replace. Okay, so here it has to be like this as well. So we want to replace this with this. Do I have to skip it? Where is my... Why are you complaining? Why are you complaining? Okay. Will this work? And that, guys, is why ChatGPT is important. Okay, thanks, SQ. We got some solution here. Let's see whether this is actually legit. Please stop this one. Okay. Oh my god. I'm calling a wrong variable. No, it's still single. I still see single quotations. to have CMD instead of element in the for loop. Yes, yes, I made a mistake, but I corrected that mistake. I'm still trying to figure out why is this not giving me double. Should I create a permutation here? Nope. So this is, guys, this doesn't make any sense. This will not work because there are no single, this is just string, so it's not a literal. So that's why I'm seeing single, because there are no quotation marks inside of the actual string. Okay, what I can do is go to launch and just replace using the find and replace, I guess, directly in this file. Can I specify somehow to focus only on this file? So I want to replace this with this, but in a particular file, i.e. this file. Replace all, preserve case, files to include, launch JSON only. That's the only file. Okay, awesome. Looking good. Looking good. And then we can say replace all. Let me just see whether indeed the last variable here is log interval 100. Yes, it is. So let's hit replace all. Yes, here it is. Magic. Okay. Let's rename it to train. Okay, let me quickly compare this. Be dense. I think, as I said, these two are gonna be the same pretty much. Looking at this, it looks like they are almost the same, if not the same. Lengths. And then fully sharded. Why is this specified? This is a bit longer. DDP, fully sharded. Whoops. Let's make a break there. Max updates, synchronize, checkpoints, max tokens. Update frequency, share all embeddings. TensorBoard. TensorBoard log dir. Transformer. Hey Gabriel, I have not done such a thing, but I doubt I'll have time to do those videos, honestly, over the next period. I'll be just streaming how I'm working on this project. Keep interval updates, maybe one day, who knows, but currently I really don't have the bandwidth. Seed validation. Okay, let's just compare now these two. D and then let me just see how I can do this. I'll have to zoom out a bit so I can compare it myself quickly. Okay, so partition is different, but everything else looks the same. Memory is different, as I said before, but everything else looks the same. This is the same. This is not quite the same, but this is. Max updates, synchronize. Okay. Learning rate. All the same. Okay. Architecture. Dropout. Keep interval. Symlink. Looking good. Same. Same. Okay. So memory, and I could have reused this one, but I wasn't sure. So the only thing is memory and Dragon. Let me save this. Let's go to the function that we need to call, which is, where is the train script? Here it is. Sweep this one. Let's set train. Let's kick it off. I'm not sure what's going to happen because of cluster none, but we'll soon find out, I guess. If backend slurm, why is backend set to slurm? Why is backend set to slurm? I guess that's the question. Backend. Okay, if I don't specify it, then the default one is set to slurm, which is hard-coded. Okay. There is some local flag here. Run job locally. Let me quickly see what's the difference with this one. Why do we have label smoothed cross entropy here and not the same thing here? These two definitely look differently. Try import JSON and JSON dump-s on the list. Hey Coley, thanks for the tip. I think you're probably all watching up. You're behind real time. But yeah, I could have done JSON dump-s. Good point. I just ended up doing VS Code search and replace. Let me quickly see this. Memory efficient FP16. Where is that specified? Trainer. Okay. Max updates. Task translation. We don't even have a task. Wait, what's going on? Wait. We don't have a task. How is this? This is not train. We just ran the train script, right? We ran the train script and task was not even there. Task is not even there. Okay, we should be good. So I'm just worried a bit about these settings here. We should probably set local because we're trying to run this locally. Language direction, data, number of trials, GPUs, nodes, local experts, languages, frequency, baseline, finish, dry run, local or debug. One of these two might help us. Checkpoints, log there, backend set to Slurm, partition. What's the default partition? None. Okay. Sequential time constraint, snapshot code, snapshot root, no tensor board. Okay. We might have to add local. If we specify local, what will happen? I don't see assert not local. Okay. Let's go. Let's enter here. Aha. So local just sets number of nodes to 1, which we already have done. So we don't have to set local. Get the grid product, shuffle, launch the train, snapshot the code. We grab the ISO format, replace this with this, so we get a code, and then we copy all Python files from current directory to the snapshot, Slurm snapshot code. Let me just understand where this is going to be saved. Slurm snapshot code. Farsec, efarsec, and farsec CLI. And then we change the, let me see what this does. Copies following files from source to destination. All Py files at direct source location. Recursively. Okay. Where is that created? Slurm snapshot code. Nowhere. Destination. Give me the absolute path, man. Import OS. OS apps. How does one get the absolute path? I forgot the command. Python absolute path. OS. OS path, apps path. Okay. So underneath farsec, directly in the root of farsec, there should be this project somewhere. Okay. Here. Fourth, 9th. assert that it does not exist, then we make a directory. Okay, let's just delete all of these. And then we go and we just copy paste everything. Okay, fair enough. Set environment. Let's continue. Number of trials. Run setup. Number of total GPUs. Save directory is going to be underneath model checkpoints, and then this whole huge directory name that consists of all of the settings. Create it and return. Copy the environment. Get the train command. Okay, let's see this one. Python. Interesting. We call the actual file from the snapshot. Then we extend. Okay, so this is probably what I was looking into before. I was copying the final command before we call the final script because we're still in this transitionary stage. Get the random port. Get the data. Okay. TensorBoard directory, extend. If there is no okay. Train command looks like this, and then we extend with this. Hit F5. We get a ton of different new flags. Generate the post command. That one is empty. And then generate, given the train commands, given the post commands, given all of this, we generate the srun, which is again slurm thingy. So here, let's see, I guess it's gonna use memory and partition somewhere. Let's see. Prefix. Okay, we can skip over that. CPU bind. What is this? Map LDOM 000111. Have no idea what this is. I remember seeing it before, but I didn't really remember it. So let's ask ChatGPT. Probably some, I'm not sure. Okay. You're configuring CPU binding or CPU affinity settings for a process or a task. Appears to specify the CPU binding configuration. It seems to be using a format where the CPU cores or CPUs are mapped to specific logical domains. It's mapping CPU cores to logical domains. And map LDOM could refer to a specific mapping. CPU core assignments to logical domains with 0 and 1. Where was this? Why is this? Where is this specified? I guess that's the question. And why this number? Okay. We are currently in Slurm. So here it's set as a default value inside of the get arguments sweep. This is the same place where we saw local. Okay. Okay, we'll have to deal with that a bit later once we start getting errors. As alloc set to false. Why is that set to false? Was it maybe triggered by me setting the partition to none? Okay, again, so run against current allocation. This is again the same. Okay, let's continue. So the base command gets concatenated with this one. So apparently, I don't see how this can be modified. Local run goes here. Okay. So we might have to set local run. We'll soon see. The reason I want to kick off a local run is because I don't really, I mean, I have a Slurm cluster, but I don't really have the Slurm cluster in the sense multiple machines and a bunch of GPUs. So it's much more powerful for me to be able to stop the execution, dig into the code, understand what's going on. So if we were setting dry run, then we would be going for the local run and then calling it here. Otherwise, we are entering here, creating a job name, getting as patch command, job name, number of GPUs. Okay. hit F5. If partition exists, then we set the partition. So this is the first time that I've seen, okay, it's gonna set the partition to none as a literal name, none. So that's not definitely going to fail. And then memory again says we have to set it to something that's non-zero, although likely less important if we go local. Okay, here we are. Write the git commit, open the train log, grab the git commit, print it to that file. Okay, just some bookkeeping to make sure we can reconstruct stuff. And this is it. Now it's going to open the train log and run the batch. And this basically opens the process with the batch command. And then I guess this is gonna kick off the run there. And this is gonna now fail completely because, yes, exactly. Invalid partition name specified, of course, as expected. And we are done. Okay. So we got some understanding of what's going on. What I suggest we do is set local flag first and see what's gonna happen then. So go to train, set the local flag. I'm gonna set it on the separate line so we remember we added it there. Okay, just a note to myself. Let's go back to the sweep. Let's kick it off again. Enter. Why do we always do this? Why, if I comment out this, then what are we going to run? Let me just see for a second. If I do this, then backend main is not even defined. There is no backend main here other than this. Okay. Get grid, launch, snapshot, continue going here. Get the train command. Okay, something failed. Something failed here. Okay. Let's see what's going on. Again, let's enter sweep and let's kick it off. hit F5, we are here. Copy Python files. Okay. Set environment. Run setup. Okay. If the job is not valid, continue. So it just ends here for some reason. What makes it not be valid? Do we have any message here? Even if we did have it, I can't read this. Let's just go and rerun it. Now we have a breakpoint there. Hit F5. Is job valid? Aha. Okay. I think we just have to clean the output or something. It thinks for some reason that we started by looking at modulo checkpoints. So let's find the modulo checkpoints dictionary directory. Here it is, and let's delete all of this. Or maybe not the checkpoints, I downloaded those before. Let's just do it like this. Move to trash. This as well. And now we should not be hitting this issue. Run. What hardware am I training on? Chicken asks. I have two RTX 3090. Okay. F5. We are good now. Get the train command. What changes if we have args local? Okay, looking good. This is still just a Python program. There is no slurm. Let's continue. Post commands. What exactly are post commands? Post steps, none, so we just don't return anything. Okay. And then get srun. Okay, so this always happens. We're always gonna hit the srun, which means we are always going to CPU bind. Srun command. Okay, local run. Train command, Python. Aha, got it. So in this situation, we ignore the srun command and we just grab the train command. And that's it. Hey Talmade, nice to see you here, man. Thanks for the kind words. I guess maybe check some of the blogs I've written. It's gonna be hard for me to tell you here on the stream exactly everything. Also join the server if you haven't seen it already, and for all of you who haven't seen this, join we have the Meta NLLB replication. I'm gonna probably just rename this to, right now, to Open NLLB. And then you can contribute either by helping around data or doing some data analysis or even helping with training. I'm a native speaker for Malay and Chinese, so I can help with those two languages. Awesome. Let me just promote this person to Open NLLB. Okay. So what's set for our CUDA visible devices? Let me see this. 0 and 1, good. Subprocess open, train with these settings. Okay, guys. So we can now run this manually without having to go through Slurm. And that was the whole point. I think we are there. Again, let me just dump this because I don't want to run this as a process. So let's just print it here as a string. Copy. Go to launch.json. And then paste it here. And then copy this one. Rename it to train local. Meta NLLB is no language left behind. That's the machine translation model that enables you to translate between 202 languages. Let's delete all of this. And let's put this here. Okay. Let's just replace again this with this in launch.json. And let's hit replace all. Looking good. So because we'll be calling train command directly, we don't have to have this prefix. Let's just extract all of this. I think this is going to be similar to the direct train above here. Okay. Save directory. Why not just change it to something simpler for now? Or no, let's just leave it be as it is. Okay. Okay. Actually, I want to put this just below this guy because it seems they're similar. Yeah, awesome. Glad you like it. Again, join the channel, join Discord here for more information. Open NLLB project. I made an announcement. Let me see whether. Okay, this changed automatically when I changed the name here. That's Discord is smart enough. Cool. Just join the channel here and you'll get more information. Good. Checkpoints saved there. PB log, just to make this a bit shorter and more manageable. Now that we are still just trying to run this end-to-end, I don't care about uniqueness of the strings and those being informative, so we can just give it some boring name. Max updates, length pairs, sampling temperature 1, atom inverse square root, stop mean LR, clip norm label smoothed, weight decay 0, 0, criterion best checkpoint metric, label smoothing should be the last one here, C2 JSON. Okay, these two look the same. Valid subset, keep interval updates. Okay. Validate interval 1000. Enable M2M validation. Decoder normalized before. Min params to rep. And then, why is that shorter? Encoder normalized before, optimizer. I think I'll have to remove this FP16. That requires Apex probably. Source. Let's break it here. Just a couple more thingies and we are done. Lengths. Decoder length token. Okay, lengths txt. And then save encoder layers. 12. Decoder layers. Encoder embed. Okay, let's just break it here. Attention head 16. And we're done. Train. Nice. It looks pretty much the same. I could have reused it, but I didn't leave any comments, so I wasn't sure what's going on. So again, the below one is for sweep pi, and the above one was for train pi, local. Okay. Data. Let me just see whether all of this makes sense. Memory efficient. Okay. Max updates. Let me just quickly zoom out so I can compare. look the same. Okay. Let's kick off our run and see whether this works. Is there any mention of memory? That's the only thing I care here. Nope. There is no mention of memory. And is there any mention of partition? There is no mention of partition, so we should be good. Okay, let me zoom in. Let's go to train pi. That should be under parsec CLI, train pi, here it is. Let's kick it off. Okay, run. Something went wrong there, or wait. All looks good. Looking good, guys. Enter the main. Infer the method here. Okay, there was some error there. Infer single node init. Yes. Let's go. Okay, TCP. Distributed main is the function we'll be calling. Okay. Put a breakpoint here. Okay, some error happened here. Datasets should not be an empty iterable. And I doubt I did pass an empty one. Let's see what's going on. Spawn, distributed train, translation, concatenate. Length of datasets is empty for some reason. Let's see what happened there. Okay. It's happening in concatenate data pi line 27. Here. I think I remember this. You can see my previous breakpoints. I've said this a couple of weeks ago. I forgot most of the things already. Now let me kick it off again. Let's stop this. Let me stop this. Let me kick it off again. And okay. Okay, looking good. We are now inside of the... Okay, maybe there was some synchronization issue while I was debugging. let's just see how this goes. Set up the task. Load languages, we don't care about that. Okay. And then this guy, let's just kick it off, guys. Let's kick it off. Let's disable all of the breakpoints and you can run freely. Let's see what is going on. Okay. Hitting some issues. Again, concatenate dataset. Okay. Should not be an empty iterable. There is some issue there. Probably not parsing my data set path correctly. Okay, then there is one solution I can do here. Just put a breakpoint there and disable all of the rest. Again, wait, what was the name of that file again? Concat dataset. Here it is. Put the breakpoint there. Go to train, rerun, and see what happens. Okay. We can also add weights and biases support. Okay. For some reason this is empty. Let's see why. Datasets. Datasets. Load split datasets. Okay, it might be because I don't have any evaluation datasets. Yes. Validation. Why do I have to have one? We can put a dummy one just to solve the issue. Or we can put Flores 200. Okay. Let's stop this run. Let's kick it off again. Whoops. Before we get to that breakpoint. Okay, here we are. Validation split. Let's enter. Okay. It might also be the fact that we are using BCP47. Maybe there are some weird expectations. Let's see. Let's enter here quickly. I might have changed some of this code, by the way, in a way that's incorrect. Let's see. Main, there's a ton of data here. Language pairs. Okay. Retrieve that back. Data paths. Okay. get the splits. Again, same thing. Okay, so for data category and paths, we split the paths. Fair enough. And then for the split and for these paths, get the shard number of, let's see what it does. We go through the paths, we list the files, and all of these are trained, as you can see. Okay, all of these are trained. That's shard 0. Then we split them. We go through the files. Okay, if the file starts with that, then we add it, which will never happen. So that means we end up here. And then we just repeat this for the next path, etc. And for the next path, and for the next path, and we just end up with empty shards. And that's causing the issues, I guess. Let's see. Lang pairs of data category. We just grab the language dictionary directories. Okay. Okay. Get dataset key. Let's see what this does. Return some key. And then if this exists there, otherwise and then we keep on repeating that for all of the next ones, and we never get to anything. So we just hit F5 and we get to what? Empty, valid, empty. Number of shards, nothing. And then we go here. Split paths. Not available, skipping. Not available, skipping. Not available, skipping. And we end up here with the empty list. And so because of that, we are going to end up with empty data sets. And because of that, we won't be entering here. And then we try and load empty list, and that's where we hit the issue. So we try and concatenate the empty one, and that's where we hit the issue, basically. That's it. This is where the assert fails. Okay, so I'm not sure why there is a hard expectation to do this. If we go to the main, maybe if we just remove the from the data set, how did we get valid subset here? That's a question. Why do we have this set to valid? when I didn't specify that anything up there, right? So in the launch JSON, I do not have valid specified anywhere. Okay, I actually do. Valid subset is valid here. If we remove this temporarily, what will happen? Let's rerun. Let's just stop this. Let's rerun the train. Hit it. Okay. Hopefully the split is, no, the split is again valid. This is gonna fail again, I guess. Yes. Why are you so annoying? We can of course in a hacky way just remove it, but I'm trying to understand what is specifying it. Obviously, I expected this one to be. Let's see what else is valid. Skipping valid size, validate interval, enable M2M validation. Maybe some of these three flags is specifying and forcing us to use the validation dataset, which we don't have, by the way. Let's try and get this to run. That would be great success if we got this to run tonight, and then we can start iterating on the whole pipeline. I can share all of these configs, and more people can set up this on their machines, and then we can start playing a bit and asking for compute as well in parallel. Okay. Let's go to train again. Yes, Bosch, I'm using the ML rig. Plus I bought one more GPU. For only 750 euros. RTX 3090, completely brand new. Let's see this config. This config file. Yeah, that's a steal. I should probably buy more. But I don't have, I would have to rebuild the rig. New motherboard, new everything. Okay. Let's see. Looking for these arguments in config. I'm gonna put a breakpoint there, and let's retrigger the run. Let's see, where do we specify config dataset valid? Is it already in the beginning there? Valid is there. anything in there that says valid. No, there is not. So when does it happen? Import module common. Add defaults, maybe here. Probably here. Dataset. Is there anything to do with data here? Let's just exit. Let's see whether now anything has changed. It doesn't look like that's the case. So where do we assert? Config. Set up the task. Criterion. Okay. I don't get it. Where did we add this? Oh. Okay, it was actually there from the get-go. I now see it. So that means before we even come here, we already have it specified. Interesting. Let's see. Where is main called? Config arguments. Parse arguments. Do we have? Let's see where that thing is called. I never specified this, if I recall correctly. README. Test. Okay, confused. Okay, default value is here. Yes, but I commented it out. I literally have it commented out. Okay, one thing we can quickly do just to solve this quickly is valid subset. Well, one thing we could do is just comment this out. But that's probably not the best thing because maybe later it's going to expect something. So let's just hard code this to none. Potential solution. Let's stop the run. Let's disable all of the breakpoints. Run, disable. Let's kick it off. Moment of truth. Non-type has no attribute split. Oh my god, why? Why? Line 153 in train. Uh-huh. Let's see what there is literally a function code that says raise valid subsets unintentionally ignored. I intentionally tried to ignore them, but it did not work. Guys, I just want to run this without valid data set. What's wrong with that? Can't a man have a simple desire? Am I asking for too much of this life? Just a simple training run without no validation data set. That's it. Humble. Okay. Ignore, combine, disable. Haters gonna hate, man. Disable validation. Aha, disable validation. Yes, yes. Why didn't I set that to true? Why am I stupid? Ignore unused. Combine valid. Disable validation. Let's just set disable validation to true. That's what we're gonna do. That's the proper solution. Find extra. Okay, here it tries to, this is where it's gonna crash because it tried to do that. Okay, let's see where this data set disable validation is used other than here. Apparently only here. Okay, disable validate, do validate. We are not gonna validate because we disabled validation. Yes, sir. Where can I specify that? As a flag. Disable validation. Disable validation. Okay. I don't see it specified here, so I can just hard code it always. I can just go here. Let's find my hack. Let's just instead say disable validation. True. Stop the run. Stop the run. Go to train. Run it. Almost there, guys. Almost there. Running this in a way that was not designed. Yes, we skipped over that. Are we gonna fail again? Yes, we are failing again because datasets should not be an empty iterable. Okay, then we need to do the following thing. Let's set this also to none. or to empty string, so that it's not complaining here. So it tries to split it. It tries to split it, but it doesn't get anything, so it fails and it doesn't enter here. Okay. Looking good. Stop this whole thing. Rerun. Hacking the FairSec code base. There must be a proper way to set this up with ignoring the validation, but I didn't see where to specify it, so I'm just hacking it right here. Hopefully this time it works. Let's go. Why? Bro. Just please ignore it. Ignore that line. I don't want to load it. That's it. Disable validation. We don't need it, and we don't need the validation. That's it. This should work. I'm fairly sure this will now work unless something else starts failing. That's unrelated. Let's see. Okay, here we are. Yes. Hit the 5. Please don't fail. Please don't fail. Just run. No. 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 Oh, okay. FP16 atom stat is only supported with fused atom. That's it. I did anticipate this one. So this is okay. Let's go to long JSON. Train local. Let's find that. Okay, here it is. Until we install Apex, which we will definitely need, we need to ignore this one. Let's stop the run. Go back to train. Go back to train.py. Here it is. Rerun. Let's go. We should be good. Okay. Okay, guys. I see some good signs. Let's not be too happy before we see the results. Seems it's progressing. I hear the sound of my GPU, man. Oh my god. Praise the Lord. Wait, NVIDIA SMI. Oh yes, guys. 20 gigabytes, 17 gigabytes on both GPUs. We are running. We are running. This is the unique moment in the history of mankind. Oh my god. Nice. Nice, 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 nice. I see some results. Epoch update loss 16.5. We are getting some results, guys. Here is the epoch number 1. I hear the humming of my GPU. That's a good sign. That's a good sign. What is the expected training time? No idea. No idea. We have to measure, I guess. We can estimate it. We can estimate it. I don't even know how many parameters we currently have in a checkpoint. Is this a 600 million model? Maybe. It's a 12-layer transformer encoder decoder. Okay, here's a second. The loss just exploded. Oh no, it did not. I'm kidding. 16.5, 13, 39.7. Obviously, we don't have validation, so we don't really know whether we will be overfitting, but We can translate the sentences from the trained data set. We can just ask the user politely, please, here is the reference. This is the set of allowed sentences. Just use these. Never ask anything else, okay? If you obey that rule, everything will work perfectly. What a customer experience. The amount of bad humor and trolling. But man, this is running. I'm super happy. Let's share this moment with Discord. Okay, my whole Ubuntu is now glitching. Let's share this. The whole pipeline is running end to end. Just getting started, guys. Just getting started. Okay, let's see. Let's see how fast is this going. So loss seems to be going down. Let's see whether, let's do one more thing. Let's see weights and biases, and let's try and estimate the number of so this is still epoch 1, update 0.25. I'm not sure how to parse this. This update variable is probably going from 0 to 1, and then we go to the next epoch. I'm not sure how they're measuring. We can always step into the code and see number of updates. Okay, so this is the thing we're tracking. Number of updates 600. We can quickly estimate how long this is gonna take on my machine. By seeing how long it takes for 1,000 and then roughly extrapolating for 100,000 steps. 100x the time. It doesn't seem it's too long. Like it's almost 1,000 and 100x that time. So maybe let's 10 minutes times 100. That's like 1,000 minutes. How many hours is that? 18? Maybe like a whole day of training. I've done more with Whisper, honestly. Okay, guys, let's see. 16.6, yes. SQ, let me add you as the let me add you the role open NLLB. You are now part of the, this is the first time you commented here, so I'm putting heart on your comment as we are speaking on the stream. Fun. Okay, let's see weights and biases. Can we set it up somehow? Where can I pass the Where can I pass the API key? So a couple of hacks here to ignore validation, and we got it running after extracting the parameters, after going through the data preparation stage. Everything is running. I'm really happy. This is now a matter of grinding, getting more manpower, getting more compute, being pedantic, basically visualizing different parts of the pipeline, iterating, and we're gonna get there. We are going to get there. Weights and biases, or maybe VanDB like this. Okay. When do I start tomorrow? That's a good question. I will always start around 10:30. There is only going to be a single day, and that's going to be actually on Sunday. I have some wedding that I have to just go to, but I won't stay too long, so I might skip. No, actually won't skip anything. I'll just start earlier. I'll be streaming in the early morning, like from 9 a.m. to like 12 p.m. Then I'll go for the wedding for like 2-3 hours, and then I'm back streaming again. So that's the plan. Otherwise, 10:30 a.m. every day CET. Oh, I sometimes have like 15-20 minute delays, but like roughly in that ballpark. Yes. Dude, I'll either die or this project will just come to fruition. It's gonna work. That's all I'm gonna say. Not many options. Let me just see how I can set up weights and biases. This is slowly starting to heat up. The GPUs are already acting as a heater. Okay, progress bar. Train step. Validate step. Train step, validate step. Okay. So what do I need to specify here? Where do we actually specify the project? And if we enter here, let's see, VanDB. Okay, if the project is specified, then we enter here and we pass in the run name. Okay. Hi Zvezdan, you missed the glorious moment, man. We got it to run. We're currently training. I'm using my GPUs as a heater. Let's see what's up here. We initialize. Can I run this without the API key? I'm not sure how this is gonna function. Okay, we're already at 1300. We can add, do we have any, is it logging the time? It is. Let's quickly estimate, guys. Let's quickly estimate how long this will take on my machine. So we started here. Updates 100, epoch 1. Time step 1057. And then let's see, where is it? Here, number of updates 11.6. Okay, so it's roughly 10ish minutes. So it's indeed 16 hours. Thanks, Vezdan. So it's gonna be like 16 hours to get some results. Now, one thing I'm curious about is how big this checkpoint is. Are we actually running 615 million model or not? Let's quickly estimate model checkpoints, save directory. So this is where we'll be saving the checkpoints. Let me open up the containing folder. When was this saved? This was saved at 11:05, which is at 1000. Exactly. That's, I've set it up so that it's saving every 1000, and then it just has these here are just symlinks. I think these are just symlinks to the actual checkpoints, so we can quickly validate that, but it doesn't matter. Now the part that's confusing is why is this 7.2 gigabytes on shard 0 and then shard 1 is 34 kilobytes. That's weird. So a couple of tasks I want to do here. First, enable weights and biases, and then compute number of params with current settings. By the way, guys, this is 16 hours estimate for 100,000 steps, assuming we're not using Apex. We can always enable Apex over the next couple of days. Enable Apex if I'm about to train on my system. So that's an additional thing we can do. Okay. Okay, guys, let's try and tackle a couple of these. I think one good thing to check out is this. I'm curious about this, and also weights and biases, and then we can go and enable Apex. After that, we'll be able to see the metrics, which is cool, as it's training, and then we can start iterating. For the final runs, obviously, because there is like a ton of mine data, like 450 gigabytes, I can't run that any serious training on my setup, just because too much data and too little compute. I would need, I guess, at least 4 GPUs to run the, I would need 4 GPUs to run the 3.3 billion checkpoint, at least. Probably even more, right? Because if this is 600 million, that's like, we need at least 4x more GPUs. With this VRAM, of course. So I'd need a whole, like a node to train, and that would be just a single data parallelism equals 1. So very slow. We couldn't even, it would be very slow to run it. So we definitely need a couple of nodes to run this, and some more to iterate and experiment. So one thing we need to do is calculate the needed number of GPUs, say A100, and compute hours. This is going to be a very important task, because with this we go for a grant. We're getting close to this point. I still want to do some footwork on our side before we go there. Okay, let's first see weights and biases. The project is specified where, and then the run name. Okay, I can stop the run now, just so that I'm not eating my, like this beast is eating eating electricity. Our electricity bills have skyrocketed like 5x, just because I was running Whisper and some other stuff locally a lot. Okay. Let's go here. Let's kick off the train. Zvezdan, really? Okay, my FPS died because GPUs are trying to train. Okay. That's because I think I'm using NVIDIA encoder as well. Okay, should be better now. Is it better now? Okay, awesome. Oh, wait. Why didn't we hit the... Okay, let's just see. Let me just see something. By the way, I think every day we have more and more viewers. That's cool. People are getting hyped up about the project as well. Why didn't we hit this line here? Progress bar. Let me see. I want to specify the project and the run name. Okay. The project is set to none. And the run name is probably also not set up. And then because of that, it's just gonna grab the base name, which is saved directory, which is not really, okay, this is not specified. And then it's gonna try and do this, which is gonna return a very dull name, save directory for the run name. Just a second, let me think. Let me think here. Where is this common? Where is this specified? Oh, maybe it's specified like this. Let's see. By default, it's none. Configs the project. Okay. There is the progress bar, which is actually using it. So it seems this is the only place where we set it up. Common config. When do we hit this? Where do we hit this? Why is everything so more complicated than it has to be? I just want to see where, okay, go back here. Configs. Hit F5. Huh. Okay, nice. No, again, the same thing. Hit the 5. Okay. This will not work. Let's just go here. Let's go to the main. We're running this directly, CLI main. Somewhere here, we're probably calling all this. Argument parser, parse known, parse known. Somewhere in this hell here, we specify the common config. Here it is. Common config. Exactly here. Okay. Which means, by the way, I could have specified this directly in the one JSON. I want to just get some familiarity as well with configs and how stuff is being run. Okay, let's just set this to something. Okay. Did we change anything else other than this and this? No, we did not. Okay. NDB project. Open NLLB. Okay. Let's go to train. Kick it off. Okay, common config is here. So get train parser grabs this parser here, which grabs the common config. Okay. And then train, just get here. Okay. I didn't specify the correct argument, so probably we have to do something like this. Fun. Okay. Config common. Do we see the NDB project set to open NLLB? Sounds good. Okay, we can hit F5 to get to here, to train step, and then just enter the progress bar just to make sure we've specified it and it works. Let's go. Let's go. Progress bar, NDB, Go here. Okay. It is specified. What? Project. Come on. I literally specified WinDB. Okay. Oh. If it's master, okay, just one of them will specify it. Okay, the other one will just ignore it. Okay. This one should be able, yes. So out of 2 GPUs, only one is able to do it. The most boring run name in the world. We should probably modify this, otherwise we'll hit some issues. Has no attribute epoch. Oh my god, that sucks. Why isn't this easier? Just, oh my god. Even in Eleuther AI, GPT-NeoX, when we were playing with the codebase, I just specified in the end file WinDB like API key and everything was working here. More complicated than that. Okay. Just make sure we have unique names, and this should be called Open NLLB. Will work for now. Okay. Now, why are you not working? We go to the WinDB, we pass in the bar, the project and all of that. Okay, definitely not. We don't need any key here. If anybody has an idea, let me know. Don't watch me suffer, guys. This should be easy. This should be really, really easy. Out of all of the things we've been doing, this should be easy. It's not. Why? Bar does not have epoch. What does that even mean? Go train. Come on. Hit F5. Okay. Okay, bar, project, name. TensorBoard. Wait, should I specify something else here? Handler, log format, JSON. So we have a JSON progress bar, okay. And then if this is true, then oh. No, I think we just have to not specify the TensorBoard log directory, and then it will work, because otherwise it's wrapping in this. Maybe that's the issue. Yes. So it enters here. It enters here. It tries to grab the epoch, but it does not exist because, okay, let's go disable tensor board log directory. Let's just comment out this guy. Let's go back to train. VenDB. That's not the right script. Okay. Stop, and rerun. And guys, we're gonna wrap up this very soon. Hello, Siddhartha. Greetings for NYC. Let's kick it off again. We got the model to run, by the way. That's the update. We have everything set up now. Now we're trying to just set up weights and biases. And after that, well, there is a ton of work, but step after step. I want to figure out what's the size of this model as well. Okay. Okay, it has the epoch. Guys, this might work. This might work. It has the prefix. This might work. Yes. Oh, no. Yes, and then no. We did not install. Let's go here. Let's activate this. Let's pip install weights and biases. Yes. Nice. Let's again trigger this again. Late night debugging sessions trying to get weights and biases to work. So there were a couple of steps. We had to first set the project. We had to remove the tensor board. We had to install the weights and biases. Fun. Okay, almost there. Let's go. Let's go. We have weights and biases. Yes, sir. Here's the project name. Here's the run name. Please do not disappoint me. You did disappoint me. Why? API key not configured. Cool, WhenDB, log in with your API key. That's what I was looking for, but like usually that's set up in the environment. So how do we, where do I set it up? Wait. Set up DB API key. Okay, so I guess we have to once set it up. Python import WhenDB. WhenDB.login, was that the case? Yes. Let me maybe do this on the other screen and then create account, use an existing account. I'm going to use the existing one. You can find the API key here. Whoops, almost. Well, it's kind of semi-hidden, so paste the key, appending the key true, appending key for API to your file. Okay, looking good, guys, looking good. Seamless experience. Rerunning it multiple times to finally get there. We're finally there, I think. Fairly confident. Not 100%, but fairly confident. Train, trigger, run. This was debugging in its full glory. Let's go. Okay. Almost there. Here we are. Enter. Init, please. Please. Mighty please. Oh yes. Oh yes. Currently logged in. Run data save locally. View the project at this location. Just open it up, bro. Here we are. No metrics showed because we are not logging anything yet, but that's soon gonna change. Kicking off the run. If this is running, we are just on a streak, guys. We are got the model to run, got weights and biases set up. Let's maybe write down the steps for setting up weights and biases. Setting up weights and biases, pip install WhenDB basically, and then WhenDB login. Paste your from your conda.env. Paste your API key. Terminal will prompt you and give you the URL. Also, make sure you don't have Tensor board logdir in your launch JSON in case you are using VS Code. And what else did we hit? We also had issues. Yes, we have the setup, and then finally set vendb project or some other name. We can add this to some README or something later. Guys, look at this. Full glory. Again, it's running, so maybe it might be a bit slower. Everything is glitching, guys. It's a combination of Ubuntu, which is already not that stable, and running the system at the very edge. Okay, let's see. So this is just system. Let's see whether we have any losses here and stuff like that. Loss scale, perplexity. What's going on? Where do we... I want to see loss curve, guys. I want to see a loss curve, and then I can sleep nicely. Why is the loss going up? No. No. Is it laggy? Let's wait. Wait 1 more minute to get some data, and then I'm gonna turn the training off, otherwise we won't be able to otherwise it's gonna be glitching. It's sending every 5th frame. Yeah. Let me see the loss. Just a second, guys. Why is this not displaying? Are we in the right? I hear my GPU. Okay, here it is. Epoch 2. Oh, number of updates. Oh, nice. It picked up a second checkpoint, guys. That's the thing. It picked up some of the previous... It's smart enough to just restart the run from the previous checkpoint. That's cool. That's a cool feature. And the loss is just going up and down, up and down. But important thing is, guys, we have this working. I'm gonna stop the run. I'm gonna stop the run. Kill this process. Okay, I've killed it. My speed should now be faster again. Hopefully the video is now again not lagging. So let's quickly, let me just add this to a README, and I'm wrapping up this. I'm wrapping up the stream for today. Let me just go to modeling train script. And then let me just paste this. Actually, let me just grab this and put this into a README here, directly in the train. Okay, so make sure this is the case. You don't have the TensorBoard log directory set up. Okay. We run login from your conda env. Then copy paste your API key. And then for set argument in your launch JSON to open NLLB or some other name. That's it. Making sure I'm writing down some of these findings along the way. I can also share the settings here, but maybe for the next time. So that's done. Tomorrow we're gonna do this. And then we need to push out the changes. There is a ton of things we have to do, guys. But off to a good start. Wrapping it up for today. It's almost midnight in Serbia where I am. So time to finish. Guys, see you tomorrow. This was very, very, very cool stream. I really enjoyed it. The magical brain just wrote something. Okay, awesome. Yeah, no worries. I mean, there is a ton of hours I've put into this, so it's gonna be hard to watch everything, but you can just start watching. You don't have to catch up, honestly. Maybe watch a couple of things if you want, or skim them. Cool. Good night, guys. Good day wherever you are, or maybe good morning. And see you tomorrow, 10:30 a.m. CET. Again, if you haven't seen this, join the OpenNLLB channel in the in my Discord server, the Epiphany, and then you'll see all of the details there. We have a ton of stuff you can contribute as a language champion. If you speak some native language that other people don't speak, do check it out. So the OpenNLLB channel is the name of the channel, and let me show you this document as well. So quickly, we have this document here, and a ton of people. Whoa, my God! A ton of people started adding their names, basically becoming the champions for their language. So do check this out. All of this is linked directly in the server here, so that's the best thing to do. I'm gonna, if you want, I can paste the link to Discord server if you're not there. Let me just paste the link quickly. So here is the link. Just a second. Discord live stream. Paste it to chat. Hopefully YouTube will give me will not block that URL. But that's it. Okay, guys. Cheers. See you tomorrow.